You see, AI doing all this incredible stuff, right? But have you ever wondered what's going on under the hood? Well, it turns out there's a secret weapon, kind of this hidden engine, that's making it all possible. Today, we're pulling back the curtain on the database revolution that is quietly powering modern AI. Okay, let's just jump right in with a question that gets to the heart of it. When you ask an AI to find, say, shoes for running in the woods, it doesn't just scan for those exact words, it gets that you probably mean trail running shoes. So how does it make that leap? How does it understand meaning? That's the puzzle we're going to solve.
So here's the game plan. We'll kick things off with this new kind of search. Then we'll meet our two main players, the long-reigning champion of data and the up-and-coming challenger that's built for AI. We're going to put them head-to-head, see why all this is a game-changer for the AI revolution, and then we'll look at how they might just be teaming up.
At the heart of this entire story, it really boils down to a fundamental conflict. It's a battle between two completely different ideas. The old world, which is all about finding things with perfect, rigid exactness, and this new world, which is about finding things based on contextual closeness.
And this slide, it just nails the core problem. For decades, computers were built to find precise, exact matches. You search for invoice number 123, you want exactly invoice number 123. But AI lives in the messy, nuanced world of human language, of images, of ideas. It needs to understand that car and automobile are conceptually close, even if the letters on the screen are totally different.
So let's start with the reigning champ, the technology that has been the absolute bedrock of our digital world for over 40 years, the relational database, or as you'll often hear it called, the RDBMS. Think of it as the ultimate, supreme organizer.
You know, the best way to picture a relational database is to think of a meticulous librarian. I mean, everything is perfectly structured in tables with these neat rows and columns. It uses a special language, SQL, to find information, and it follows this super strict set of rules, called ACID compliance, to make sure not a single piece of data is ever lost or messed up. It's built for a world of absolute certainty and, you guessed it, exact matches.
But as we know, the world of AI is anything but neat and tidy. It's just flooded with unstructured data. All that text, all those images, all that audio. And to handle this mess, a new challenger had to emerge, the vector database. It was literally born from the needs of this new, complex landscape.
So if the relational database is our librarian, the vector database is more like a creative art curator. It doesn't just store items, it understands the relationships between them. It's designed to find what's similar, not just what's identical. And it does this by converting everything, words, images, you name it, into a complex list of numbers called a vector. That string of numbers basically represents its meaning, its vibe, allowing the database to find what's close at incredible speed.
All right, it's time for the main event. Champion versus challenger. Let's put them side by side and really break down the crucial differences in how they work. This is where we get into the technical magic.
Okay, before we dive deep, here's the high-level cheat sheet. You can see the split right away. Relational databases, they're for structured transactions using SQL for those perfect, exact matches. Vector databases, they're for unstructured AI data, using similarity search to find related items. So the key takeaway is, they're optimized for completely different jobs.
Now, what's really fascinating here is how they fundamentally see data. A relational database sees the world as a giant spreadsheet, everything organized into perfect records. A vector database, on the other hand, sees the world as this huge, multidimensional map, where similar concepts like king and queen, or puppy and kitten are actually plotted close together.
And that difference in worldview, well, that leads to the biggest payoff. Let's use that example. If you ask a relational database for the word automobile, it's only going to find records that contain that exact word. Simple. But a vector database? It understands the concept of an automobile. It knows the vectors for car and vehicle are nearby on that conceptual map, so it brings them back too. That right there is similarity search.
But how on earth does it do this so fast? Well, a relational database uses an index that's like the index in the back of a book, perfectly ordered for exact lookups. A vector database uses these really clever algorithms, one's called HNSW, and they fall under a category called approximate nearest neighbor, or ANN, and the key word there is approximate. They trade a tiny, insignificant amount of accuracy for a monumental gain in speed. It's how they can search billions of items in the blink of an eye.
So really, this all comes down to a totally different philosophy. The relational database is like a bank vault. It's all about that ACID compliance, meaning every single transaction is guaranteed to be perfect, consistent, safe. The vector database, though, is built for the chaos and scale of the internet. It prioritizes speed and getting you a relevant answer now, even if the data is only eventually consistent across its network.
So we've geeked out on the tech. Now let's see how this actually builds the AI tools we're all using every single day. Why is this challenger, the vector database, so incredibly important right now?
This quote just says it all. These things aren't just a nice-to-have add-on. They are the cornerstone. They're the engine driving this massive architectural shift in software, the shift from searching for keywords to searching for meaning. Without them, so many of the AI applications we take for granted just wouldn't be practical.
Okay, let's look at a super concrete example, something called Retrieval-Augmented Generation, or RAG. This is how you make a big language model smart about your own private data. It's simple, really. First, your question gets turned into a vector. Second, the vector database instantly finds the most relevant documents from your company's internal files. And finally, the LLM uses that specific, accurate info to give you an answer, which prevents it from making stuff up.
And it's not just for chatbots. This same technology is what powers the recommendation engines on Netflix or Spotify that seem to read your mind. It's behind the search bars that actually understand what you're looking for, not just what you typed. And it's even used in cybersecurity to find anomalies, like a fraudulent transaction that just feels different from all the others.
As you'd expect, this is a super hot area, and there's a whole ecosystem of companies popping up. You've got specialized vector-native databases like Pinecone and Milvus, but you're also seeing the veterans, like Elasticsearch and Postgres, adding powerful vector capabilities like the really popular pgvector extension. It's a huge sign of just how critical this technology has become.
So, is the old champion being replaced? Is it getting knocked out? Well, not exactly. See, the final chapter of this story isn't about a knockout. It's about a team-up. The future, as it turns out, is hybrid.
The winning strategy that's emerging is something called the polystore pattern. And it's a simple but really powerful idea. Don't try to force one tool to do everything. Instead, use the best database for each specific type of data. You let each player do what it does best.
And this is a perfect example of how it works in the real world. A company might use a rock-solid relational database like PostgreSQL to handle their critical customer and transaction data. That's the world of exactness. But with the pgvector extension, that very same system can also power their AI-driven product recommendations, the world of closeness. It's literally the best of both worlds. And that leaves us with one last big thought to chew on. For about a century, our information systems have been built on a foundation of absolute precision. But as AI pushes us to make sense of a much more chaotic, unstructured digital world, it forces us to ask a really interesting question. In the future, will our ability to understand what is close in meaning become even more valuable than our ability to find what is exactly the same?